Linear search. Linear search is an algorithm for searching through elements of an array. Let's look at it in action. Let's try searching for number 7. First, we examine the leftmost number in the array. We compare it with 5, and if it matches, the search ends. If it does not match, we examine the next number to the right. In our case, we compare it with 9, and we see that 7 is not equal to 9, and we continue to the right number. In the next stage, we compare it with 3, and we see that 3 is not equal to 7, and we continue to look right. And in this case, we have 1 here, which is not also equal to 7, and we have to continue to the right. We repeat comparison until the 7 is found. It continues to compare with 8, then 4, and then we reach 7. When we found the 7, the search ends here. As you can see, linear search is a simple technique for doing repeated comparison in order from beginning of the array. When there is a lot of data, the number of comparisons increases and it takes more time. And the time complexity for linear search is O(n). Advantages and disadvantages of linear search. The primary advantage of linear search is its simplicity. It's extraordinarily easy to understand, and the implementation is very easy. From an operational standpoint, linear search is also very resource efficient. It does not require copying and partitioning of array being searched, and this is memory efficient. It also operates equally well on both unsorted and sorted data. The primary disadvantage of linear search is that it has very poor general efficiency. The time complexity is O(n), and that is the performance of algorithm scales linearly with the size of input. For the general case, linear search thus is considerably slower than many other search algorithms. In certain cases, where additional information about current contents of the list being searched are known, linear search can perform as good or better than many other types of search. For instance, if you can assume that the list you have is FIFO or LIFO, and you know that the item you are looking for is either almost always recently added or almost always at the end of list, then tailored linear search can provide very good performance. Binary search. Binary search is an algorithm for searching through elements of pre-sorted array. Search a sorted array by repeatedly dividing the search interval into half. We begin with an interval covering the whole array. If the value of search key is less than the item in the middle of the array, from here, we narrow the interval to the lower half. Otherwise, we narrow it to upper half. Repeatedly check until the value is found or the interval is empty. Okay, let's try searching for 6. First, we look at the number in the center of the array. In our case, it's 5. And we see that 5 is less than 6, which means that the number 6 is located at the right of 5, because we are looking into pre-ordered array. So we remove the numbers that are no longer needed, which are in the left of 5. In the remaining numbers, we again look at the number in the center of the remaining array. In our case, 7. We compare 7 to 6, and we see that it's greater than 6, which means that the number that we are looking is located at the left of 7. Again, we remove the numbers that we don't need. In this case, we remove 7, 8, 9, which are located in the right of 7. In the remaining numbers, we start to look for the center, and this time we see that we have only one number left, which is 6, and we compare it with 6, and we see that it's equal to 6, which means that the searching is finished. Advantages and disadvantages of binary search. One of the main advantages of binary search is that it's one of the fastest way to search for an item. The performance of binary search is log n. And the main disadvantage of binary search is that it requires elements to be sorted.